Bismillahirrahmanirrahim. Welcome to the Electronics One. In this introductory class, we will explore the fundamental concepts of electronics, including basic components like a resistor, capacitor, diode, transistor. You will learn how these components work together to create a circuit, as well as how to read circuit diagrams and use essential tools. This course is introductory for beginners, so no prior knowledge is needed except simple circuit analysis work. By the end of this semester, you will have a solid foundation in electronics that will prepare you for more advanced topics and practical application. Get ready to engage with the hands-on projects and discover the exciting world of electronics. Welcome. Electronics is a fascinating field that revolves around the study and application of electric circuits and components. And its core, it's involve understanding how basic elements like resistor, capacitor, inductor, and semiconductor devices interact to control the flow of electric current. These components have various functions from storing energy to regulate voltage, enabling the creation of complex devices like smartphone, computers, and home applications. Additionally, electronic encompasses both analog and digital systems, each with its own unique principle and application. As technology continues to advance, the importance of electronics in our daily life only grows, making it an essential area of study for aspiring engineers and hobbyists alike. Resistors are a fundamental component in electronic circuit as well as electric circuit, serving various critical functions that ensure proper operation, protection, and signal integrity. Understanding these roles is essential for designing and analyzing both simple and complex circuits, complex electronic systems. So, firstly, resistor, as you know, that it's limit current flow, and similarly, capacitors, it stores electrical energy temporarily. Inductors store energy in magnetic field. Diodes allow current to flow in one direction only, and a transistor act as a switching or amplifier. All these aspects of electronic fundamental elements we will discuss in detail in this course. Functions of resistors in electronics can be defined with following aspects. The most important is current limiting. Resistors limit the amount of current flowing through a circuit. There is essential to protect sensitive components like light emitting diode and transistor from excessive current that could cause damage. Similarly, resistor is also used for voltage division. Resistor can be used in voltage divider circuits to produce a specific voltage output from a higher voltage source. This is useful in many applications, such as sensors reading. Similarly, biasing is another important aspect of resistor application. In transistor circuits, resistors are used for biasing, which sets the operating point of the transistor. Proper biasing ensures that transistor functions efficiently in the application amplification or switching applications. Another important aspect of application of the resistor is signal conditioning. Resistors are often used in combination with capacitors and inductors to filter and condition signal shaping the frequency response of the circuit. Similarly, the last most important aspect of resistor is heat generation. Resistor converts electrical energy into heat through the dissipation of power. It can be useful in some application like a heating element. However, this could also be a drawback if the heat is not managed properly. Capacitors are essential component in electronics like a resistor, serving multiple roles in various applications. Here are the key functions and characteristics of capacitors. The most important is energy storage. Capacitors store electrical energy in an electric field when a voltage is applied. This stored energy can be released when we need it, making capacitor useful in power supply circuits and energy storage application. Smoothing and filtering is another important application of the capacitors. In power supply circuit, capacitor smooth out voltage fluctuation by filtering out noise. It is one application. Many other application of the capacitor for smoothing and voltage fluctuation you will find in electronics. They can help to convert alternating current to direct current by reducing ripple voltage. Another important is timing and oscillations. Capacitor works with resistor and inductor to create timing circuits and oscillators. They determine the timing interval in applications like clock circuit and pulse generator. Coupling and decoupling is another important application. For coupling circuits allow AC signal to pass between stages of one circuit while blocking direct current from one stage to the another stage. This is important in audio and radio frequency applications. Another important application for decoupling capacitors. Bypass capacitors is high frequency noise and stabilize voltage level in power supply circuit, ensuring stable operation and behavior of digital circuit. Similarly, phase shifting in AC circuits, capacitor can create phase shift between voltage and current, which is crucial in applications like motor control and signal processing. And the last but not least, signal filtering. Capacitors are used in conjunction with resistors and inductor to create filters like low pass filter, high pass filter, band pass filter that allow certain frequency to pass while blocking other frequencies. These are the few applications of a capacitor in electronics. Inductors are fundamental component in electronics, playing several key roles in various applications. Here are the primary functions and characteristics of inductors. The most important is energy storage. Like capacitors, inductors store energy in magnetic field when electric current passes through them. This energy can be released back into the circuit when the current decrease or sometime increase. Current smoothing is another application for the inductor. In power supply circuit, inductors help smooth out current fluctuations, providing a more stable output. They resist abrupt change in the current, which is useful in applications like DC to DC converter. Filtering inductor can also used in conjunction with capacitors to create filters. For example, low pass filter and high pass filter. They can block high frequency signals while allowing low frequency signal to pass, making them essential in audio and radio frequency applications. Transformer. Inductors are the building block of a transformer, which creates transfer of electrical energy behavior between circuits through electromagnetic induction. This is crucial for voltage conversion in power supplies. Energy transfer in resonance circuits, it is the most important application for resonance circuit. In resonance circuit, inductors works with capacitor to create oscillations at a specific frequency. This is important in radio frequency application and oscillator circuits. Inductive loads. Inductive loads are used in devices like motors, and solenoid, where they convert electrical energy into mechanical energy or vice versa, or perform work in electromagnetic field. Phase shift inductor also introduce a phase shift between voltage and current in AC circuit, which is important in power factor correction and reactive power management. Electronic devices have two semiconductor devices. One is diode and another is transistor. Diode's main application is rectification. Diodes are primarily used to convert alternating current to direct current. This process is known as rectification and it is essential in power supply circuits. Similarly, clipping and clamping, diodes can clip or clamp voltage level in the circuit. Clipping diodes limits the voltage to a certain level, protecting sensitive components from overvoltage. Signal demodulation in communication systems, diodes are also used to demodulate the signal. They help to extract the original information from the modulated carrier waves. Another application of the diode is voltage regulation. One specific type of diode called Zener diode is commonly used to maintain a constant output voltage source across a load, providing voltage regulation and protecting against voltage spikes. Overvoltage protection, diodes can protect circuits from voltage spikes. Sometimes it is referred as a transient by converting or diverting excess voltage away from sensitive components. It is commonly used in surge protector circuits. Similarly, switching diodes inherently can act as a electronic switching in circuits, allowing or blocking current flow based on the applied voltage. Similarly, light emission is another application of the diode, specifically light emitting diode. Light emitting diode basically emit photons as a light when current flow through them. They are widely used in displays, indicators, and many light applications. Photo detection is another important application of the diode. Photodiode can convert light into electric current, making them useful in light sensing application. Similarly, solar cell is also considered a specific type of photodiode. So all these are very important application of the diode. I'm not expecting that you have to be expert of these terminologies. I'm just introducing these terminologies and application of the diode. You will study all these aspects of the diode as well as transistor. Not only this course in electronics to analog IC and digital IC, many other future courses. Transistors are vital component in modern electronics, fundamentally as a switching or amplification purpose. Here are some key roles and characteristics of transistor. The most important application of transistor is switching. Transistor can act as an electronic switch, controlling the flow of current in a circuit. They can switch on and off based on an input signal, making them essential for digital logic circuits and power management. Another application is amplification. Transistor can amplify electrical signal, increasing the power, voltage, or current of the signal. This is very crucial in many applications like audio amplifiers, radio frequency amplifiers, and signal processing circuits. Signal modulation. Transistors are also used in modulating circuits where they help encode information onto carrier signals. This is important in communication systems such as radios and televisions. Voltage regulation. Transistor can be used in voltage regulation circuit, maintaining a constant output current despite varying input voltage and load conditions. Oscillations. Transistors are key component in oscillator circuits, generating periodic signal used in clock, timers, and various type of transmitters. Level shifting, they can shift voltage level in circuits, enabling interfacing between different voltage domains, such as connecting low power microcontroller to high voltage devices. And the most important application of electron of transistor is digital logic design circuits. In digital circuits, transistor serves as the building block for logic gate such as AND gate, OR gate, NOT gate, forming the foundation of digital computing and modern information processing. Thank you.